Hello, I'm Clarence Mayotte, an application engineer for linear technology. For the past 2 years, I've been working with high-speed ADCs.
And I'm Alan Davidson, Product Marketing Manager for high-end FPGAs at Altera. I've been involved with FPGAs for about 12 years now, the last 5 of them focused on applications for high-speed serial transceivers.
We are here today to demonstrate how the new linear technology LTC2274 analog-to-digital converter can easily interface with Altera FPGAs, which have embedded serial transceivers. The LTC2274 is a 16-bit 105 megasample per second ADC and is the first and only high-speed ADC to transmit data using 8B10B encoding, compliant with the JEST 204 specification. It uses a single differential transmission line pair to seamlessly interface with Altero transceiver-based FPGAs, dramatically reducing the number of I/O lines required to transmit data. Let's get to the demo. The LTC2274 requires 3.3 volts, a clock signal, and an input signal. The connection between the output of the LTC2274 and the Altera Stratix 2 GX FPGA is only 2 matched cables and a single wire for the synchronization signal. A complete procedure and list of demo boards that are used in this demo is available by registering at the end of this video. Alan will now discuss Altero Transceivers.
Let's take a look at the whiteboard. Here is a block diagram of the LTC2274 connected to the Altera FPGA. In the FPGA, the embedded transceiver is configured to receive 8B10B encoded data. The user logic is configured with a simple design that implements a JEST 204 compliant interface. Data is received by the FPGA and sent to a clock and data recovery unit that samples the data and recovers the clock. This eliminates the need for any clock signals to be forwarded from the linear technology ADC to the FPGA. The data is then deserialized and decoded back to the original samples that were created by the LTC2274. Since all of the required logic blocks are already included in Altera's embedded transceivers, you don't have to worry about recovering and decoding the data sent by the analog to digital converter. Instead, you're free to concentrate on the logic required to complete your application, which is the most valuable part of your design.
Once the data is collected, it can be formatted and imported into any data analysis program. Today we are using Linear Technology's P-Scope software. As you can see, the LTC2274 has excellent AC performance. With a 70 MHz input signal, we are getting a signal-to-noise ratio of 76 dB and a spurious-free dynamic range of 88 dBFS. This is the same performance you can expect from an ADC with a parallel bus, but we are only using a single matched pair of cables to connect the LTC2274 and the Altera FPGA.
Altera offers several full-featured and cost-optimized FPGA families that contain embedded serial transceivers. These include the Stratix 2 GX and Aria GX families, and the recently announced Stratix 4 family, which is the industry's first 40nm FPGA. In addition to embedded transceivers, Altera FPGAs are rich in high-performance DSP, logic, and internal memory resources. These are required to implement functions such as decimating filters and digital down converters that are used in applications such as software radio, communications infrastructure, and test equipment. To learn more about Altera products and embedded transceiver solutions, visit the Altera website or contact your local Altera sales office.
In addition to our LTC2274 ADC, Linear Technology and Altera have been working closely on developing complete power and other analog solutions to support Altera-based systems. You can greatly increase productivity and mitigate risk by using one of the many Altera development boards that have approved linear technology solutions.